I welcome you all to the 9th video lecture in Computational Intelligence. In this video lecture, we are going to discuss regarding knowledge representation and first order logic. And this concept belongs to the unit 2 of Computational Intelligence. And let's begin this knowledge representation with the first slide. In the first slide, basically, we are going to see what is meant by knowledge and what is the use of representing the knowledge. As we all know that knowledge is basically an information about the domain. And what are the domain we are going to implement in artificial intelligence and both in computational intelligence. We are going to withdraw the information, and the process of withdrawing the information is said as a knowledge. And what is meant by knowledge representation? Here, the knowledge representation is nothing but how we can encode the knowledge, beliefs, goals, desires, preferences, and all mental state in artificial systems is said as knowledge representation. In simple way, we can say that how we are withdrawing the knowledge from the domain and how it is represented so that the user can identify the knowledge being taken from the artificial intelligence. That's the fact is said as in knowledge representation. And what to represent, what are the things we are need to represent in the knowledge is the next slide we are going to see. And basically the 5 things has been given regarding the knowledge representation. The first one is object, and as we all know that object is nothing but a fact, the fact about the objects. If we say human, and we are going to explain object as its attribute like legs, hands, eyes, nose, and what are the parts of the human body are referred as an object. And similarly, events is nothing but the action which occurs in our world, that is the action which the objects can perform. For example, reading, writing, sleeping. These are some of the action that perform using the objects, and all such actions are referred as an event. And meta knowledge is everyone knows knowledge about the knowledge. And facts are nothing but the truth about the real world and what we represent. Facts are nothing but it gives a truth about any object. He is a human being, it is an animal, and all the facts regarding the objects represented using the facts. A knowledge base is nothing but the database, and central component of the knowledge based agent is a knowledge base. All the details regarding the data has been stored in the knowledge base. Basically it's represented as KB, and it contains a group of sentences, and the group of sentences are referred as a knowledge. And what are the types of knowledge we have? And we have 5 different types of knowledge. The first one we are going to see is meta knowledge, and second is heuristic knowledge, third one is procedural knowledge, fourth one is declarative knowledge, and fifth one is structural knowledge. And what is meant by meta knowledge? As we all know that meta in sense it gives a knowledge about the knowledge. If we gives about the address, it gives the pin code of the address being withdrawn. The knowledge about the knowledge will be seen in the meta knowledge. And heuristic knowledge represent the knowledge of some expert in a field or a subject. It gives a collection of knowledge regarding the proved well-known fact of some expert. For example, if we take a physics, on all the laws we have Newton first law, second law, third law been proved by the expert Newton. All such knowledge will be stored in the heuristic knowledge. And third one is procedural knowledge. Procedural knowledge is nothing but the knowledge or information about how to achieve something. It gives the procedure to achieve the goal state, and the goal state will be mentioned, and we need to withdraw the procedure knowledge to obtain the solution for the given fact. That is said as a procedural knowledge. And next one we are going to see is declarative knowledge. Declarative knowledge, whenever the term declarative comes, it refers about the objects. Objects is nothing but before we have seen that what is meant by object is a real world entity. An object And declarative knowledge gives about what is mean by object and what are its attribute and what are its behavior in relation with it. For example, if we see a car and what are its attribute is, we have steering, clutches, and motors, engine, everything comes under the attributes. And what is mean by behavior is, with the help of all the objects, what we can do, what are the functionality we can perform. We can drive the car, we can stop the car, we can move fast the car, and all other functions are set as in behavior. So the collection of what is mean by the attributes and what is mean by objects and what are the function it can perform collectively said as declarative knowledge. Similarly, car is said as an object and various attributes of the car is said under this attribute, and whether the various functionality the car performs comes under the behavior. And studying about all such statement is said as declarative knowledge. And what is mean by structural knowledge? The structural knowledge is nothing but it gives and describes the relationship between different objects, and it gives a relationship between the various objects in the knowledge. And these are the 5 different types of knowledge, and it's very essential to know about all these 5 types of knowledge. And that type of knowledge is represented in the form of diagram. Here we are seeing about what is mean by knowledge. In sense, knowledge is differentiated into 5 types. What is mean by declarative knowledge? It gives about the facts. And heuristic knowledge, about the rule of a thumb or a knowledge of the expert. And meta knowledge, the knowledge about the knowledge. Procedural language, it gives rules and procedure about the knowledge. And finally, structural knowledge. Then structural knowledge represents the relationship between objects and its concept. And general representation, basically we can represent in a 2 way. First one is logical representation and non-logical representation. And logical representation basically means representing the knowledge in terms of some logics, and representing some knowledge apart from the logic is said as in non-logical representation. And logical representation in turn is divided into 2 types of logics. First one is multivalued logics and second one is model logics. And what are the way, what is mean by multivalued logics? And firstly, multivalued logic is nothing but it is the truth, more than two truth values in a given logic. It is said as in multivalued logics. Example, true and false would be the 2 values. Here true, false and unknown value, three values been given for a fact, therefore it is said as in multivalued logics. In addition to this multivalued logics, it also combines the concept of fuzzy logic. Fuzzy logic has been explained in the previous video lecturing, and which defines the degree of truthness, whether 0 or 1. We basically used to say it predicts if it is 0, what percentage will be coming under its 0, if it is 1, and what percentage of 1 will be coming under the fact. That will be explained using this fuzzy logic. And secondly, model logics. Model logics nothing but model operators used to define a mode of propositions. Example, epistemic logic and temporal logics. Epistemal logic and temporal logic are the 2 examples for the modern logic. And other than the logical representation, we have non-logical representation. Non-logical representation, there are 3 types. First one is production rules, second one is semantic networks, and third one is description logic. Production rule is a type of rule used to explain the fact. Semantic network is a form of a network used to represent the relationship between the different facts, and description logic is type of a frames that also used to represent the logic in terms of frames. And we are going to see within first order logic. This would be the basic concept when we study with this logical representation. And first order logic, as we all know, it is a form of symbolized reasoning in which statements or sentences. If we break this first order logic, it will divide into two types, that is subjects and predicates, and we are going to see what is mean by this subject and what is mean by this predicate. And basically predicate defines the properties of the subject, and we have a subject and its properties will be detailed explained with the help of the predicates. Another name of this first order logic said as first order predicate calculus or first order functional calculus. And syntax, basically when we explain the syntax of this FOL, that is first order logic, it contains two terms that we need to know. First one is syntax and second one is alphabet. Syntax is nothing but the collection of symbols and logical expression in a first order logic, and which determines the meaning behind this expression. Syntax in sense the collection of the symbols we have, and secondly alphabets we have. Alphabets are nothing but it can be an English language to represent the first order logic in a formal way. And we are going to see the various logical symbols used in the first order logics. Firstly we will need to see about the quantifiers, universal quantifiers and the extensional quantifiers, and these two are the symbols, inverted A and inverted E are the two symbols. Inverted A is used for universal quantifiers and reverted E is set for extensional quantifiers. And here we use these symbols: conjunction symbol, disjunction symbol, implication symbol, and biconditional symbol, negation symbol. These are the various symbols we use for the logical symbols, first order logical symbols. And also here there are some authors use CPQ for implies, and instead of double directional we use EPQ, and simply horseshoe may replace the imply symbol, and triple bar may replace the bidirectional symbol. These are the certain symbols which can be replaced by the older symbol which has been used. And also we can also use parenthesis, brackets and the punctuation symbols, and these are the various logical symbols we are going to use in the first order logic. And what are the formulas we use in the first order logic? First is predicate symbol. As we all know that predicate and which tends to the various terms is the first formula. Predicate symbol formula is the first formula we use in the first order logic. And secondly we use an equality, as we all know that if T1 and T2 terms are equal, T1 equal to T2 is a formula being used. And third is negation formula. As we all know that negation formula we use an bar symbol in front of the alphabet. Negation, as we all know, if it is 0 it will return to be 1, if it is 1 it will return 0, and it invert the inputs. And binary connectives is a formula. Here a similar rule apply to other binary logical connectives. If then rule is used for binary connectives. Similarly quantifiers, as we all know, quantifiers, there are two types of quantifiers being used. First one is extensional quantifiers and universal quantifiers. And language quantifier is also extensional and universal are the two type of quantifiers, and language element which generates a quantification is called as quantifiers. And here and in the syntax to write the quantifiers and what is mean by the quantifiers is given. First one we are going to see with a universal quantification, and second one is extensional quantification. Universal quantification is an inverted A. Syntax is inverted A, variables and sentence. Universal quantification of X predicate is true in a model if P is true with X being each possible object in a model. For example, everyone at Berkeley is smart. can be represented using the above universal quantification methods. And similarly, extensional quantifier is an reverted E variable sentence. Reverted E to the power x P is true in a model if MP is true with an X being some possible object in the model. Someone at Stanford is smart. This can be represented using the universal quantification in the above way. And we'll see a few other examples for universal and the extensional quantifiers in the coming next video lecture. And we are going to see within what is mean by predicates and what is mean by the semantics. While we are going to see with these quantifiers, it is essential that we need to know about the predicates and the quantifiers, predicates and the semantics. What is mean by predicate? Predicate is nothing but the Boolean valid function. That is, predicates basically represent using P. P colon X is true or false, where P is the predicate and X are the terms which can be true or false. And here it is an interpretation in mathematics and logic and their precise definition. And what is mean by semantics? Semantics is nothing but the interpretation of a first order language that assigns a denotation to the non-logical symbol is said as semantics. It is nothing but the domain of discourse. Very important term we need to identify is domain of discourse that specifies the range of quantifiers. It also provides a semantic meaning to the terms and the formula of the language. The study of the interpretation of formal language is called formal semantics. And where are the areas this logics being used? In the application of the logics, the thing we are going to see in this slide. First, it is used in logical programming. Logical programming is tic-tac problem. We can use this type of logics. We use in certain logics to solve this tic-tac-toe problem, and that is one of the application where we can solve problems by using uncertain logics. And in also in database, these logics are used in making queries, data mining, in knowledge extraction, in knowledge retrieval, etc. In this types of database we are using this logics. And also in digital circuits, where we use in various types of gates like AND, OR, NOT, etc., XOR. In various types of digital circuits, the application of logics are being used. Thank you, students, and I hope this video will be much useful to you. We'll meet on the next video lecturing. Thank you.